second example here in Unit 14, we've got a slightly different question than we had in Example 1. The farmer decides to use an existing stone wall as one of the walls of the animal pen. This means he will only use the 16 meters of fencing on 3 sides of the rectangle. What is the largest area he can enclose? So what we've got is we've got a thick stone wall here that is already in place, and he wants to build a rectangle, 3 sides of a rectangle, right next to it. So what he's going to have is he's going to have one width, another width, and then a length across the top. So these 3 sides, width plus length plus width, have to add up to that 16 meters of fencing. So this column right here where we've got sum of the lengths of 3 of those sides, that's going to be 16 every time, because we've got 16 meters of fencing. And we can do the same thing that we did in the first example. We can choose different values of widths, 1, 2, 3, 4, 5, 6, 7, and figure out what the length has to be. But this time, the length isn't going to change by 1 every time. Because what we get here is, if we add these two w's together, we get length plus 2w equals 16. Okay? So if our width is 1, 2 widths is 2, so our length has to be 14 to give us the 16. Okay? If our width is 2, 2 times 2 gives us 4, so we need 12 to make up that 16. So our length is going to change by 2 every time. 6, 4, and then 2. How do we get our area here in the last column? Well, same thing we did before. It's going to be width times length. Okay? So our width is 1, our length is 14. 14. 2 times 12, 24. 3 times 10 is 30. And we can keep going. We'll get 32. We'll get 30. Then we'll get 24. And then we'll get 14. So if we look at what area is doing, area again is getting bigger. It's increasing. And then once we hit the halfway point, it starts decreasing again. So let's look at our graph here. Our width down at the bottom, our area, okay, up on the side here, and we can just plot these points. 1, 14, 2, 24, 3, 30, 4, 32, and so on, and so on. Okay? Draw a nice smooth curve through them. All right. Now, what are the dimensions of the rectangle with maximum area? Well, let's see. If we look in our table, our maximum area is 32. When we had a width of 4 and a length of 8 meters. Does the stone wall allow you to enclose more area? Well, let's see. With 16 meters of fencing, here our pen has an area of 32 meters squared. In the previous question, if I flip back, the largest area we could enclose is 16 meters squared. So having that third wall lets us enclose twice as much area. So yes, twice as much. Is there a relationship between the length and the width of the enclosure with maximum area? Well, what's our width and our length here? They're 4 and 8. So our length is twice our width. Length equals twice the width. So if we can make our length 2 times bigger than our width, we get the maximum area. Okay? So let's try an example down here. Suppose we have 60 meters of fencing, just like we did in the additional question on the last example. What are the dimensions of the rectangle with maximum area? Well, we want our length to be 2 times our width. Right? So if we take our 60 and we divide it by 3, that gets us 20. So our width is going to be 20, and our length is going to be 40, because we have essentially 2 parts of this for the width, for the length, 1 for the width, which gives us 3 parts. So 20, 40, nope, that doesn't add up, sorry. Scratch that. Okay. What we want to have is, we want to have our length, be 30, okay? So that's our 60 divided in half, and then our width is going to be half of that, which is 15. Length divided by 2. Okay? So we take our total amount, 60, divided by 2 to get the length, and then we take our length divided by 2 to get the width. So our area here is going to be 30 times 15, which is going to be 450 meters squared. Okay? And that's our maximum area.